Ladies and gentlemen, it's Mike here at Game From Scratch, and today we are going to be looking at game development on the new MacBook Pros. Now, this is the first MacBook I've been interested in since like 2016 when Apple really lost the plot. And they've done a lot of things right here. These are probably the best machines out there for video editing right now, which is the primary reason I picked it up. But this is a game development channel. I want to see how well this thing would do at common game development tasks. So that's what we're going to be looking at today. I'm going to look at a number of different engines, and we're going to see what the performance is like. And we're going to start with the one that probably the majority of Mac-based developers would work with, and that is Unity. Now, what you see in front of you, this is a Unity standard pipeline project. We're going to look at an HDRP pipeline project as well. This scene consists of about 500,000 triangles, and as you can see, navigation and everything else super smooth. It definitely is a pleasant experience to work with. No complaints at all. Relative to my other laptop, it's a Razer Blade 2019 with a 2070 Max-Q, 32 gigs of RAM, and a 9750 Intel processor. This is faster. I would say it is about 30% faster when we look at raw benchmark speeds. So, for example, if I go ahead and actually play this project, we're going to see some of the stats up here. We're looking 180, 300 frames per second. We're going to start getting some things on screen here, and we're still staying at high 200s here. I'm recording this at 1080p, so 1920 by 1080 resolution. I do have video recording software running in the background, and now I'm going to show you something really impressive. Look at that frame rate right now. So we're looking 200 to, about 200-ish. And what I'm going to do is reach over and unplug my power. It's unplugged. All that changed right now, my internal display just faded a little bit, but other than that, you notice something? Zero performance drop at all. That is one of the things that probably impresses me the most about the MacBook Pros is quite simply, they run exactly the same on battery as they do plugged in. So now I'm going to plug this back in. All right, there we go. Also, I got a number of hours. So when I was playing around with this and playing around with Unity examples, installing my camera software and so on, I got about 5 hours of battery life with the GPU just screaming away. So that is quite impressive. Now, I got to admit right off the hop, Unity is better optimized for the M1 chips. They actually have an M1 version out there, so do keep that in mind. Now, the other example we're going to look at, this one is going to run a little bit slower, but for obvious reasons. This is an HDRP project, and it's over 2 million polygons in total. Now, what you'll notice is there is a little bit of a lag as it starts up, and as we navigate the scene, it is definitely a little bit jerkier. Can't disagree with that at all, but when we go ahead and run this guy, you're going to see part of the reasons why. So first off, this is using the HDRP pipeline. Second, this asset isn't incredibly optimized. This is a Snap's sci-fi scene. So here we got it running. You're going to see, look at the triangle count up here. 5 million triangles in this scene. We're running 34, 33 frames per second, so not bad at all. Now, I do want to point one thing out before we get too much further. If you're thinking about picking up a MacBook Pro M1 based for your primary machine and you want to do a lot of gaming, don't. This is not a gaming machine, but game development creation tools run just fine. They run, again, as good or better than my 2019 Razer Blade. And I'm guessing they're probably about on par with a 3060 GPU in performance. Maybe slightly better than that, but again, quite good performance overall. So that was Unity. Again, we've got two projects. If you stick to the standard pipeline, I had it still running. Oh, and you got to also keep that in mind. I'm running 2 instances of Unity at the same time and recording software in the background. And this is the kind of performance we're getting. So I have no complaints at all. This guy runs Unity as good as I could expect. The only thing I have run into so far is the light mapper. It forces you to use a specific version because it hasn't been optimized for metal yet. That will obviously be fixed in time, and if you know anything about Unity, light mapping is one of those areas that, let's just say it's in flux quite often. All right, so that was Unity. Now we're going to move on to Unreal Engine. So I already created a project. One thing you'll notice here, I'm using early access version of Unreal Engine 5, mostly because once I've gone to Unreal Engine 5, going back was definitely a challenge for sure. So we're going to go ahead and open this particular project up. Now, one thing I want to talk about is actually project loading, and it has been sweet. It actually loads projects quite a bit faster than on the PC equivalent. When it came to the Unity game engine, it imported projects probably 2 to 3 times faster than what I'm used to. And I'm running an SSD on both machines. So the SSDs in these machines, these MacBooks, are fast. I definitely have to give them credit there. Oh, I have a message off screen that's blocking me. All right, so why did you load up on that screen? So let's move this over. All right, here we go. Now, one thing you will notice is it's not really optimized for the new MacBooks yet. That is the Unreal Engine itself. So you're going to see some aspects of it that are, a little weird. So, for example, the content drawer uses the exact same hotkey as as this. So Spotlight and this are using the same thing. Little things like that, not a big deal. But here you see that, whoa, we're way too fast. Here is the default scene. Speed and performance are just fine. Obviously, I'm not going to use this as an example. Instead, let us open up a map. So I pulled in the polar map. I think this was from one of the giveaways. I got no idea when I picked this guy up, but let's go to polar. Oh, actually, no, he put it somewhere else. Where did it put it? Put it in maps. All right, so I'm going to open up Polar Facility Map right here. So you get an idea how long it takes to load up maps. Now, obviously, I've done all the shader compilations already. That part is normally quite brutal. And here you can see it in action. So this here is Unreal Engine 5 running a non-trivial environment. Again, buttery smooth. I'm actually quite impressed with how things work. Most of the things I've thrown at it, the performance were just fine. I decided to mix things up a bit by bringing a couple of character models into the scene. So let's go on down and instantiate a character. So go down here and let's grab our dragon. So I pulled in a desert dragon. You get an idea of what kind of performance we're talking about here. So let's bring the desert dragon in. So you can see instancing in a model. This guy has a fair bit of detail to him. And brought it in no problem. Now let's go ahead and, is it Control D or Shift D? Oops. Come on, dragon. Screw it. I'll just bring another one in this way. All right, so let's bring in another dragon, see what our performance does like. And where's my mouse? Oh, there it is. All right, bring in another dragon and another dragon and let's see, one more dragon. All right, so there we brought 5 dragons into the scene. No real degradation to the performance. It's still pretty smooth, pretty solid. A nice working experience. I will say Unreal Engine is equally slow doing shader compilations on the Mac as it is on Windows. That's literally just an Unreal Engine thing. You kind of get used to it in time. So one of those things to be aware of. Plus, I keep losing my mouse. There it is. All right. So is there anything else worth showing here? Let's show the FPS that we're dealing with in the editor. So you see right now we're dealing, it's probably a little bit hard to see, 80 frames per second with all of these dragons instantiated in the world. 70, 80. Let's go over here, take a look in the environment itself. So 60 frames per second going on over here. Let's kind of loop around. So you see, it's never not usable. In fact, I would actually say Unreal Engine, when we do the comparison between this and the HDRP, Unreal Engine is actually running nicer. Now, one thing you may be wondering about is heat. And I actually found running this thing on my lap, it didn't get uncomfortably hot. Unreal Engine definitely spun the fans up a little bit more than Unity did. But even then, it was really quite usable. The only thing that I found is because of the way that Unreal Engine full screens, the notch is much more noticeable on Unreal Engine. I don't mind the notch overall, but definitely it's going to be one of those polarizing things. So that here is Unreal Engine. Again, this is the 24-core GPU version, and I think most of you would agree that this is more than sufficient for most people's work. And this is Unreal Engine 5, not optimized for, I think we're running through Rosetta at this point, which is their compatibility layer to make it work with Intel instead of the M1 level silicon, and performance is great. I have no complaints at all. I'm actually rather impressed with how well this performed, and I would actually say this is also, again, outperforming my 2070-based Intel machine by a fair margin, to be honest. So I'm definitely impressed with Unreal Engine's performance, though I think in time we're going to see them, make it a little bit more Mac native, so the experience is a little bit nicer, and so hopefully it's not using the exact same hotkeys as things like, Spotlight. So that one's a little unfortunate. But anyways, that is Unreal Engine 5, I think Beta 2, running on Mac Silicon. Runs just great, in my opinion. So now we are going to move onwards and upwards to... Oh, I lost my editor. All right, there we go. So now I'll do Godot Game Engine next. In all honesty, when it comes to Godot, I had fairly low expectations because I don't know that there are too many Mac-based lead developers on it. I know it's primarily developed on Linux, and I think the lead platform for the most users is Windows. I did not have great expectations. This is the Godot third-person shooter demo, and there's a couple things I got to say. First off, it imported assets 5 to 10 times faster than my Windows machine. I was actually really shocked by that. Let's go ahead and open up the level here. So level TSCN, this guy right here. And done. All right, so here is a demo game. We're going to just kind of walk around scene. You can see how the performance goes. Definitely playable by any definition of the word. It looks good. I see no artifacting. The performance is quite solid. I've never had any real issues with it at all. When we get into the effects-heavy core area, which is, okay, I'm kind of stuck in the environment. Okay, so go over here, past this robot guy over here. There's a little spot coming up. All right, over here, let's see. And in here, there's quite a few effects going on here. And this is the only area where you might see some slowdown. And even then, I see almost none. It got a little chuggier when it got near, so we're going to chug out just a little bit here, but still super smooth. And I would actually say this runs, again, a little bit better than it does on my PC. Perfectly viable for working in the Godot game engine if that is what you want to do. And again, the part that really impressed me, so let's bring up the frames per second. So we're looking 35, 36, 37 in the editor here. Definitely doable. This demonstration has never been incredibly optimized, so the performance is, again, it's not really stellar on any machines if we're honest about things. But it does give you an idea what it is like to work with Godot. It's a decent experience. Let's go ahead and run the scene. I don't know if I can run the scene directly from here. And here you see, gameplay-wise, it's just fine. But, okay, by the way, that happens on PC too. That first instantiation of the shot does slow things down. But this is, again, comparable to the performance I get on my Razer machine, if not possibly slightly faster. Again, this demo has never been really optimized for performance, and I have no idea if you can hear that over that. Because another thing I have to acknowledge, let me get out of there, is the MacBook, hands down, has the single best speakers on a laptop in existence. As far as I've ever experienced, they get loud and they sound good. So actually, that part's quite impressive. So anyways, that is the Godot game engine. Definitely the strength I saw. Everything seems to work just fine. But what really impressed me was the file import speeds. It brought in all the textures for the third-person example in like seconds. It was pretty amazing that way. So I was definitely impressed there. So that is it for the game engine side of things. Now we're going to look at a couple of applications, typical of what you might use in the world of game development. We're going to start that off with Blender. Okay, so here we are in Blender. I'm going to do kind of a very simple stress test so you can see basically how well it pushes polygons. This is the native version, so you can download an Intel or an Apple Silicon version, which is for the M1 chips. That is what I'm using here, and what I'm going to do is just switch this default cube. The default cube is going to be the star of the show because of course it is. And what I'm going to do is subdivide it. So subdivide and done. All right, so okay, how do I turn that back on? I always forget where this option is now. What I want to do is show you the statistics so you can see what we are dealing with here. So right now we have 48 triangles. That's really not that impressive. So let's jack that up. So now we're dealing with 768, 3,000, 12,000, so 200,000, 700,000. All right, so there we go. We're at 3 million triangles on our default cube. Performance didn't lag at all. Let's see what it's like to select individual vertices. So let's do come on. We'll do a box select, grab a few like so, and we're fine. So this is an area, edit mesh for vertex handling has never been a great performer, if we're honest. So what we are going to do is sculpt. So we're looking at 3 million polygons. We are going into sculpt mode. Do keep in mind, I do have video capture software going at the same time. So if you want to sculpt something with 3 million polygons in it, there is your performance. Just fine. Another area where it really shines, you'll see in a lot of benchmarks, people that don't actually use Blender, they just kind of use it as a benchmarking tool. It seems to be performing on par or better than most high-end mobile GPUs out there right now. But as you can see, 3 million polygons, I'm sculpting away, and we're all solid. So definitely the performance degradation, yet wow, so we dropped down in number. I wonder why it does that. No real big performance problems. Now, the one way I can actually bring in the beach ball, though, is if we go back to the edit mode and we select all of everything, and we do one more layer of subdivision here. So now we are going from 3 million triangles. So there is the beach ball. So do know I have a 32 gigabyte system here, and on the M1 chips, the GPU and the CPU share RAM. So if you're going to be doing sculpting of 12 million triangles, do be aware you probably want to get a little bit more RAM than I have. But again, we're pushing 12 million triangles right now. Let us go back over to sculpt mode and see how the experience goes. So switching sculpt mode, and we're in. Let's drop our radius down a little bit, and let's sculpt. There you go. Performance is just fine. So you can sculpt 12 million triangles. Again, it's dropping down by half when I'm coming into sculpting. I don't know why that is. If you know that, let me know in the comments down below. But all the same, you're seeing we're dealing with really high resolution scenes here. And again, don't forget, I am video capturing this at the same time. And again, if I unplug, no real drop in performance at all. Plus, I'm about 3 feet away from my laptop, and I don't hear my fans at all. I can tell you my 32 gig powered system with an 8 gigabyte internal GPU 2070, it would have choked at this point in time. So it's a simple example, nothing really too impressive to show you, but you can just see the raw polygon counts that these GPUs can handle. It's pretty good. And if you're wondering in terms of which machine you should you get a Pro, should you get a Max, and so on, well, this is where your GPUs are being taxed. It's in the game engine. I would honestly recommend anybody that's really in the game development side of things, you're going to want to lean towards the more GPUs, and you're probably going to want to get a minimum of 32 gigs of RAM, because again, the video RAM and the system RAM are shared. They're also really fast, and if you jump up to the Max chip, they're double speed. So it's 400 gigabytes per second instead of 200. Most of that's a theoretical thing. It doesn't really mean too much. But as you can see, the Blender experience on the M1 Max, you can push a lot of polygons and it don't slow down. Now, we did see the first and only instance of the beach ball showing up. So if I go back over here, I'm going to do one more subdivision just to make my computer really cry. And this, again, we're switching modes. There is the beach ball. So this is the area where you start choking your machine, and this was just a stupid thing to do because I think we're going well beyond the capacity of what it should be able to handle. So we're at 12 million right now. We're waiting for the subdivision to finish. Again, a beach ball showed up, so we definitely have some lagging going on. We're probably swapping out a little bit, but again, not bad at all. Let's see how long this actually takes. Again, I may have bitten off more than I should have or can chew here, but we shall find out in just a second. So I'm going to give this, say, 15 more seconds to run. If it doesn't finish, then I think we found the theoretical limits of what we can handle here. But yeah, let's find out what happens. So we're going to be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right. May have pushed it a little too high again. Oh, we stopped spinning. I don't know if that's a bad thing or a good thing, because I definitely may have found the upper limits of what a 32 gig system are capable of. Oh, there we go, 50 million. We didn't crash, we're fine, 50 million polygons. Let's go over to sculpting. This is going to be a little timely because, there's 50 million polygons here. But let's see if it is still workable when we get over to sculpt mode. So again, this is going to take a little bit of time for it to switch. So obviously you're pushing the outer limits of what's comfortable to work with, but quite reasonable limits, I would say, that we're at. And my PC would have choked at this point in time for sure. Let's see if sculpt mode finishes loading. Give it a couple of seconds. Again, 50 million triangles. That's pretty insane. So here we are. The viewport still orbits just as well. We can zoom in, zoom out, no problem at all. Let's see how well sculpting works. Sculpting works fine. Wow, that is impressive. So yeah, if you're looking at high polygon workflows, if you got a little patience, 32 gigs will get you. If you're going to be doing this kind of stuff on a regular, you probably want to move up to the 64. I would have gotten rid of that beach ball completely. Also keep in mind, there is one level higher GPU than what I'm using, so you can actually get a 32-core GPU, which again would be, if you're routinely working on 50 million polygon sculpts, that might be the right way to go. But actually, now that I'm in here, this performance is just fine. Like it's solid. All right, so that is Blender. Let us move on to just 2D applications, and then we'll wind it down. Okay, now we're going to look at a pair of programs that I use constantly, and this one specifically the most. This is Affinity Designer. This is a vector graphics application from Serif Software. It's very similar to Adobe Illustrator. I actually prefer it quite a bit myself. And let's bring down one of these examples. So this guy here, 6 megabyte file. Sure, let's bring that one in. So we'll download that example and we'll open it up. So you get an idea of what a fairly complicated vector graphics scene will be like in Affinity, and there we go. So here we see it. This is your performance. By the way, I did notice there is a brand new version. I haven't upgraded to it as of yet, so it's probably more optimized for the M1, but my performance has been just fine. So let's see what zoom in. So zooming in, zooming out, moving around, grabbing things, interacting. It's flawless. It's super smooth, no issues at all. Definitely usable for sure. So that is if you're doing like a vector graphics style workflow, as you see, moving in and out, almost infinite levels of zoom, no performance degradation at all. Things move around, super smooth, not much more you could ask for. Same deal, we're gonna move over to Affinity Photo. This is kind of the Photoshop equivalent. Let's go ahead and grab the Corel Knight here. It's a 75 megabyte project. I'll just go ahead and let that one download and we'll see how it performs. And again, spoiler alert, it performs just fine. So, mind you, my internet seems to be struggling a bit, but let's just let this come on down. Okay. By the way, if you have not as of yet, do check out Affinity Photo. It's an amazing program, and same with Affinity Designer, especially Affinity Designer, actually. I highly recommend both. Both are available on Windows and Mac, and a really cool tip I just found out is my Windows key actually activated my Mac version, which is quite sweet. All right, so here we see, open up this document. It's, again, 80 megabytes. It's 4618 by 6890 in size. Performance is rock solid. So if you are working on pixelish art stuff, let's go ahead and draw something here. You see brushes are super smooth. Everything works great. Your performance zooming in, zooming out is near to flawless, almost infinite level zoom. Performance never drops. So if you're doing pixel art-ish type work, definitely a good performer. And then let's come up here and do a filter on it. Let's add, let's do a clarity filter on here. So let's see what it's like. Is it not real-time preview? I thought it was. So see, filters basically immediate. Same thing with what else can we do? We can do some layer adjustments. So let's say we want to do I don't know if I have anything that's apply a LUT. So there you see everything pretty much real time. So the performance here for 2D work, be it vector graphics for this case, or this case pixel or raster graphics, or vector graphics as we saw in Affinity. Keep in mind, they are again both running at the exact same time, at full speed, with video capture going in the background. So if you're looking at 2D pixel art, this, in all honesty, this is overkill. You probably get by with the entry level or maybe even the MacBook Air at that scenario. But the M1 works really well, especially with Affinity software. I imagine Photoshop and Illustrator will at least get a patch eventually to make them perform just as well. But I gotta say, like across the board, everything I have thrown at this thing, the performance is great. And then when it finally comes to video editing, I find it encodes, and this is why I ultimately picked one up in the first place, it encodes what I would say probably 2 to 3 times faster than normal. So that is definitely a nice thing there too. Now, I'm not saying that everyone should go out and buy a MacBook Pro, especially if you are a gamer, because gaming, there's barely anything out there. They probably have 1/50th or 1/100th of the games that you get in Windows World. And the performance is anywhere from okay to good, if it's natively made, but there's only like dozens of natively made games. A lot of things are running through Rosetta, which still you get, really good frame rates from them. But when you're starting to run Windows-specific titles through emulation, be it either through Parallels or the other one, Crossfire or Cross Trigger, whatever the heck it's called, your performance definitely suffers as does compatibility and so on. So if you're looking primarily as a gaming machine, I can get away with that because my other machine, again, is a solid gaming PC. But if it's your only machine and you want to do all of these things and gaming, MacBook Pro probably isn't there for you because the gaming experience isn't amazing. But the other stuff, the content creation, the using of game engines, I haven't really run into a tool or a program on this platform that hasn't performed well for me. So, yeah, that's my experiences. Not raw benchmarks or anything, but you get to see real world what things perform like, and I gotta say, across the board, I'm pretty impressed. So I know some of you just straight out knee-jerk hate Apple. I'm not a big fan of the company themselves. I haven't liked a MacBook Pro since 2016, but these new ones, people are hyping the hell out of them, and frankly, the hype is pretty deserved. So let me know what you think. Comments down below. Talk to you all later. Goodbye.